we will be starting with a new chapter, lines and angles. Okay, from our class 9. Okay, so here in this chapter, lines and angles, we will be learning about various theorems, axioms related to lines, and what are the various properties related to angles and all. Okay, so if you see lines and angles, this is something which is we can find very common in our lives. Okay, if you see this board also, it is made up of lines. Okay, now angles also, if we want to determine the position of a plane, okay, which is flying in the sky, or the distance of a ship. Okay, these lines and angles have a huge role in our maths, in science, in engineering and all. So it is very important for us to learn about the various properties related to lines and angles. Okay, so let's see. Okay, so we know a line. Line is a collection of many points which can be extended in any direction and it does not have any width. Okay, so if you see a line can be extended in any direction. Okay, then the next term that you should be knowing here is about line segment. Okay, line segment. So what do you mean by line segment? Segment means a small part of the line. Okay, if I have drawn this big line, if I am taking a small portion of it. Okay, I am taking a small portion of it. This small portion I will call it as what? I will call it as line segment. Okay, so a small portion of a line is called as a line segment. So if I name this line segment as AB, then I will represent my line segment as like this. Okay, I will put a arrow mark over here. So this is the way in which I represent the line segment. Okay, now our next term that we have to learn is about ray. Okay, what do you mean by a ray? Okay, so a ray means when I talk about line segment, I can extend it in any direction. But when I say about the ray, it should start from a fixed point and it extends and go. Okay, that is the difference between a line and a line segment. About rays. Now our next term that we should learn is about collinear and non-collinear lines. Okay, collinear. Okay, so what do you mean by collinear lines? If I say there are 3 points A, B and C. Okay, these are my 3 points A, B, C. If these 3 points lie on the same line, okay, if you see over here, A, B and C are lying on the same line. If any number of points lie on a particular line, we will call them as collinear. Okay, now if I say A point is over here and the point B is over here and let's say point C is over here and I am drawing a straight line like this. Now if you see over here, A point and B point are lying on this line. But what about C? It is not lying in this line. This point is not lying in our line over here. So it means that this A, B, C is not collinear. Okay. So this is the way we see. We have to see whether the 3 points A, B, C are lying on the same line. If it is lying on the same line, we can say it is collinear. If the points, okay, if you want, I can take one more point here, point B. Here also I can take a point E. Here also if you see this C and B point is not lying in this line, so we cannot say that it is collinear. It is a non-collinear line. Okay, so that is the difference between collinear and non-collinear. Okay, so now we understood collinear and non-collinear. Now let us talk about what angle is. Okay, you have been learning from your lower classes itself what an angle is. We know angle means two rays starting from a common point. Okay, let me name this O and B over here. Okay, so if you see, an angle is actually a collection of two rays which starts from a particular point. So here OB is my first ray and OA is the second ray. And this common point, okay, the common point where the two rays substance is called as the vertex. Okay, VERTEX. Okay, the common point where the two rays meet is called as the vertex. We can also call these rays as the arms. Okay, we can also call them as arms of the angle. Okay, so when these two rays meet at the common point, we will be getting an angle over here. Okay, so now let's learn about few types of angles. Okay, these are something which you have learned in your lower classes itself, but let's see. Okay, so there are different types of angles. For example, the first one is acute angle. Okay, we know what do you mean by acute angle. Acute angle means it is the angle whose measure is in between 0 and 90 degree. So all the angles between this range, we call it as acute angle. For example, 30 degree. Okay, we know 30 lies between 0 and 90. Between 0 and 90, any number, if it makes the angle, we call it as acute angle. Okay. Now the second one is right angle. Right angle means that the two rays, they subtend an angle of 90 degree. If the angle made is exactly 90 degree, we call it as right angle. Okay. Now the next one is obtuse angle. Okay, so obtuse angle means the angles measured should be in between 90 degree and 180 degree. Okay, for example, 135 degree. We know 135 lies between 90 and 180. Now, if you see over here, from 0, if you see the angle is going like this and it goes like this. Okay, now that is obtuse angle. Now the next one we know after this comes like this, it rotates and it finally becomes a straight line like this. Okay, so when it finally becomes a straight line like this, the angle made will be 180 degree and we call it as straight line. Okay, first of all it starts from here, it rotates, it becomes 90 degree, again it rotates like this, becomes obtuse angle, again it rotates and finally the angle becomes a straight line. Okay, whose measure is 180 degree. Now from here also you can see it can rotate in the anti-clockwise direction also like this, isn't it? Okay, so here you can see the angle whose measure is in between 180 degree and 360 degree. Okay, we call it as reflex angle. Okay, we call it as reflex angle. So I have taken an example of 216 degree. So if you see 216 lies between 180 and 360. Okay, similarly this can continue and goes like this. Okay, so these are the few types which I have been learning in your lower classes. That is acute angle, right angle, obtuse angle, straight line and reflex angle. Okay. Okay, so now let's learn about adjacent angles and its properties. Okay, so when you say about adjacent angles have a common vertex, a common arm, and the non-common arm should be on different sides. Okay, so here if you see, I have taken an angle ABC and I have taken one more arm over here, arm or ray, both of them are same words. Okay, so adjacent angles means, okay, if you see over here, this angle CBD and ABB. Okay, these two are adjacent angles to each other. So the condition for an angle to be adjacent angle is that it should have a common vertex, then it should have a common arm. This BD is the common arm for both these angles and the non-common arm. Non-common arm means BA and BC. These are the non-common arms. They are on different sides. Okay. If the given angle satisfy all these conditions only, we can call it as an adjacent angle. Okay. Okay. There is a property of adjacent angles that you should be knowing. If you see, if I take this full angle ABC, that is this full angle. Okay, full angle ABC, then this angle ABC will be equal to angle ABD. Okay, I will name angle ABD as 1 and angle CBD as 2. Okay, so this full angle ABC will be the sum of this individual angle and this individual angle. Okay, so from here I can write angle ABC is equal to angle ABD plus angle CBD. Okay, this relation you can use if the angles are adjacent only, and we call this relation as the adjacent angle property. Now here there are a few examples which I have written. If you see this example here, you can see an angle AOB. Okay, and there is a common arm OC in between them. Here it makes an angle 30 degree, and here it makes an angle 60 degree. Now if I ask you what is the value of this full angle AOB, what will you say? The full angle will be equal to sum of this individual angle plus sum of this individual angle. That is 60 plus 30, 90 degree. That means the angle AOB, this full angle's value will be equal to 90 degree. Okay, and also there is a specific name. When the adjacent angle, when you add the adjacent angle and you get the sum of it equal to 90 degree, we call them as complementary angles. Okay, the adjacent angle whose sum gives you 90 degree is called as complementary angles. Okay, now the next one more example. If you see here, we are having the angle AOB and there is a non-common arm OC. This AO and OB lies on different side. That means this one is the adjacent angle. Now if you see the angles are 55 and 125. Now if I ask you, you can see this is a line over here, and we know the angle made by a line is always 180 degree. Okay. Now if you see, we can also prove it. Just see, if you add this number and 55 and this 125, we will be getting the measure of this full angle. Okay, so 125 plus 55, it is 180 degree. Okay, so here also we have applied a adjacent angle property. Now here also, when we add two adjacent angles and we get the sum of it equal to 180 degree, in that special case we call these angles as supplementary angles or linear pair angles. Okay, we call these are the linear pairs. If the adjacent angles when we add the adjacent angle, we get the sum equal to 180. We call it as supplementary angles or linear pair angles. Okay. So now let's learn about intersecting and non-intersecting lines. Okay, so we know what do you mean by intersecting line. Intersecting line means when two lines they meet at a common point. For example, if you consider this pen as a line, okay, and I am crossing it like this. So if you see, these two lines have a common point of intersection. Okay, if they meet at a common point, we can call them as intersecting lines. Okay, now when we say about non-intersecting lines, if you see over here, AB and CD, these are two lines. They are not meeting at any common point. It means that these two are not intersecting lines. But if you see this line AB and CD, they are lying one below the other. Okay, so we can call it as non-intersecting lines. Also, we can say these two lines are parallel lines. Okay, AB and CD are parallel. So I will write. This is the symbol. Okay, we put two standing line like this. This is the symbol we use to represent parallel. So we can say that AB is parallel to CD. Okay, so here these are parallel lines. If I draw the lines like this, okay, if I draw the lines like this, these are also not intersecting lines. But if you see, these lines do not lie one below the other. Okay, one is going in one direction, other one is going in some other direction. That means these lines are not parallel lines. Also, if you extend parallel lines nor intersecting lines, okay, such type of line which is not parallel and they are neither intersecting, we call them as skew lines. Okay, SKEW, skew lines. Okay, I hope it is clear. Okay, so now let's learn about axiom number 6.1. Okay, and its converse. Okay, so let's read. if a ray stands on a line, then the sum of two adjacent angles formed is equal to 180 degree. Okay, here's the thing that we saw earlier. Okay, that is, if you are being given two adjacent angles like this, and when you are adding these two adjacent angles, you will be getting the sum equals 180 degree. Okay, what do we call those two adjacent angles? We call them as supplementary angles or linear pair angles. Okay, so here this is exactly what the axiom is saying. If a ray stands on a line, okay, so this is the ray OC, which is standing on a straight line AB. Then the sum of two adjacent angles. So here in the example I have taken the adjacent angles are 55 and 125. Okay, then when we add these two adjacent angles, we will be getting the sum equals 180 degree. Okay, this is exactly what this axiom is saying. Okay, and also we call this axiom as the linear pair axiom. Okay, why? Because when we add these two angles, we will be getting a linear pair, and the sum of them we will be getting equal to 180 degree. Okay, now here the converse. Now converse means the same statement we are reversing it. That means here we said that if the ray stands on this line, these two angles will be equal to 180. Now here the converse, that means the just opposite statement. If the sum of the two angles is 180, okay, that means when we add this angle and this angle, then the non-common arm forms the line. That means this OC will be present on a line. That means in our first one, it was given that this ray stands on a line. If it stands on a line, then the sum will be equal to 180. Now in the converse means the opposite statement. They are telling that if the sum of these two angles is 180, then definitely this ray OC will be present on a straight line. Okay, this is the converse statement that is trying to tell you. Okay, I hope it is clear. Okay, so now let's move on to our next topic, that is vertically opposite angles. Okay, so vertically opposite angles you have learned in your 8th standard. Okay, so what are they? So we are having two lines which intersect at a common point O. Okay, so according to the vertically opposite angle axiom, if two lines intersect each other, okay, these are two lines AB and CD, they are intersecting each other and they meet at the common point O. Okay, then the vertically opposite angles are equal. Okay, so it means that, and it forms four different angles. Okay, so vertically opposite means that they're just opposite to each other. So if you see over here, this angle 1, which is just opposite to angle 2. Similarly, this angle 4 is just opposite to angle 3. Okay, I have given it 1, 2, 3, 4 for convenience. Okay, or you can say angle AOD and COB. These are vertically opposite angles, or angle AOC and angle DOB. These are other vertically opposite angles. So we know that the vertically opposite angles are equal to each other. Okay, which means if this angle 1 and 2 are vertically opposite angles, so I can say that angle 1 is equal to angle 2. Similarly, 4 and 3 are vertically opposite angles, so I can say angle 4 is equal to angle 3. Okay, why? Because these are vertically opposite angles. So I hope it is clear. Now let us see the proof of this statement. Okay, so let's see the proof of the vertically. How will we prove that angle 1 is equal to angle 2 and angle 3 is equal to angle 4? Okay, so here our main task, what do we need to prove? First of all, that you should write. Okay, we need to prove that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Okay, this is the thing that we need to prove. Now, in order to prove this, we have to use a concept of linear pairs. Okay, now here if you see this OA, this OA is a non-commoner and it lies on this line CB. Okay, what does that mean? We can say that since this ray OA stands on this line CB, this angle 4 and this angle 1, they form a linear pair of angles. Okay, so you can write this OA stands on the, so you can write the ray OA has its stance on the line CB. Angle 4 and angle 1 are linear pairs. So according to a linear pair axiom, we can write angle 4 plus angle 1 is equal to 180 degree. Isn't it? We have learned that according to linear pair axiom, this full angle will be 180 degree. So the adjacent angle sum will be equal to 180. Okay. This is we have written using a linear pair axiom. So this I can take it as equation number 1. Now similarly, if you see over here, this OD, this ray OD also stands on the line AB. What does this imply? It implies that this angle 1 and this angle 3, they are also what? They are also linear pair angles. Why? Because this OD stands on this line AB. So we can say that this 1 and 3, they are also linear pair. Okay. So from here I can write angle 3 plus angle 1 is equal to 180 degree. Okay. This is my second equation. Now what should you do is we have to equate these two equations. Now if you see over here, this is equal to 180 and this is also equal to 180. If both of them are equal to 180, we can say that angle 4 plus angle 1 is equal to angle 3 plus angle 1. Isn't it? Now from here if you see, we can cancel this angle 1 and from here also we can cancel this angle 1. So what is left is angle 4 is equal to angle 3. Okay. Isn't this exactly what we wanted to prove? Okay. So this is the angle 3 and this angle 3 is equal to angle 4. Okay. Angle 3 and angle 4 are vertically opposite angles. Okay. So from here we have proved that since angle 3 is equal to angle 4, we can say that vertically opposite angles are equal to each other. Okay. Now, if you also take any other angles and see, if you want to prove angle 1 is equal to angle 2, okay, you should take the angles in accordance with it. Now, from here, so in order to prove angle 1 is equal to angle 2, we can take these two and these two pair. Okay, so from here we said that OD, since it lies on the line AB, from here I can write angle 1 plus angle 3 is equal to 180 degree. Similarly, since this OB also is a ray standing on the line CB, I can say that angle 2 plus angle 3, this is also equal to 180 degree. Now since both of them are equal to 180, we can equate the LHS. Okay, so angle 1 plus angle 3 is equal to angle 2 plus angle 3. Okay, so from here you can cancel angle 1 and angle 3 and angle 3. So finally we will be getting angle 1 is equal to angle 2. Okay, and from here also we got angle 3 is equal to angle 4. Okay, so this was the thing that we had to prove, that vertically opposite angles are always equal to each other. Okay, so we have proven this vertically opposite angle theorem using a linear pair axiom. Okay, I hope it is clear. I hope all the things discussed in today's class are clear. Now we will be meeting in our next class with the example questions. Thank you. Please like, share and subscribe the channel.